Okay, before proceeding, I want to point out that the base of the log that we've discussed in this class, Math 119, the base, so here the base is x or 2x, so that means the x has to be greater than 0, all right? Also, we're going to say that the x shouldn't be equal to 1, all right? So let's take a look at it, and the first thing I would probably do is just rewrite it so it was in the same base, all right? And the way to do that is just use base change formula. So the left-hand side will be the natural log of 72 over the natural log of 2x. This is just the base change formula that we discussed in class and derived. The right-hand side is going to be natural log of 18, and then the natural log of x. The next thing I would do is realize I'm solving for x, so I'm going to clear the fraction, and I would get the natural log of x times the natural log of 72 is equal to the natural log of 2x times the natural log of 18. All right, the next thing I would probably do is I'm going to try to get the x on the one side. Before I do that, though, I'm going to use a rule of logs to kind of separate the 2 and the x. All right, let's write this down. So natural log of x times the natural log of 72 is equal to the natural log of x plus the natural log of 2, right? I just divided this single log into 2 logs using rules of logs, and times the natural log of 18 now. What I'm going to do now, probably distribute, and you get this. You get natural log of x times the natural log of 72 equals the natural log of x times the natural log of 18 plus the natural log of 2 times the natural log of 18. Well, I'm going to get the x onto one side. And what would that give you? I get ln x times the natural log of 72 minus the natural log of x times the natural log of 18 is equal to the natural log of 2 times the natural log of 18. Well, I'm getting close. I can factor out the natural log of x now, and you get the natural log of x times the natural log of 72 minus the natural log of 18 equals the natural log of 2, natural log of 18. All right, I'm noticing something interesting about this factor over here, that I can combine it into one log, and that's pretty easy to do. It's going to be a natural log of 72 over 18, and 18 goes into 72 4 times. So it's getting simpler and simpler. So you get natural log of x times the natural log of 4. Again, 72 divided by 18 is 4. And this equals the natural log of 2, and then natural log of 18. Getting close. Natural log of x equals the natural log of 2, natural log of 18 over ln 4. All right, I'm going to simplify a little bit further, and you get the natural log of x equals ln 2, ln 18, and at the bottom, the natural log of 4 is just simply 2 log 2, natural log of 2. Well, natural log of 2 is not 0, so these are going to cancel off. And what do you get? You get something pretty simple. You get the natural log of x is equal to 1/2 the natural log of 18. I'm almost there. Natural log of x is equal to the natural log of, well, it's 18 to 1/2, which is root 18. So now I know x is equal to root 18. This should be simplified. And simplification, I see a 9 there. Square root of 9 is 3. So you get 3 root 2s. All right? All right, that's what x is. That's what we found. It's right over here. There's other ways of doing it, by the way. I want to point out, your mileage may vary. You may see a different way of doing it. And the way I want to approach the problem is a little differently. I'm going to set both sides are equal. So I want to point out that this is identical to this. So I just, I write down, I introduce a variable, I say y equals. And what does it equal to? It equals the log base 2x is 72. And it also equals log x 18. And I'm just going to use the definition of logs to rewrite as an exponential. So what would you get? You would get 2x to the y is equal to 72. And you'd also get x to the y is equal to 18. Well, I'm kind of looking at those two equations. They look kind of difficult to solve, two unknowns. But I could do a simple division. I'll point out what I mean by that. You get 2x to the y is equal to 72. I can divide both sides by 18. And 18 is the same thing as x to the y. What do you get over here? Well, you would get 2x over x to the y is equal to 4. Well, that's convenient, isn't it? What do you get? 2 to the y is equal to 4, or y is equal to 2. All right, now certainly if y is equal to 2, the big question, what's x? All right, and that really isn't so bad to do. Let me write that down for you. And I'd probably do this one over here, probably the easiest one for me to do. So again, if y is equal to 2, you get x squared is equal to 18. And remember, x is a positive number, so x is the principal root of 18, which is, square root of 18 is going to be, there's a 9 there, so 3 root 2's. All passes to the same truth, by the way. All right, that's an optional question. Again, taking these options might be in your best interest, by the way. I also want to point out, my name is Ron Bannon, and my email address if you need to reach out to me is Bannon, that's B as in boy, the @ symbol, NNON.US. I'm also going to show you a graph of this problem. And the reason for the graph is you always wonder, did I get the right answer? All right, and I'm going to point out what we're doing over here. We're graphing, two things. And so what are you graphing over here? Well, I'm graphing, let me take a careful look at this. The blue curve is y equals log base x of 18. I'm using Grapher to graph these things over here. And this magenta curve is going to be y equals log base 2x of 72. There's a point of intersection over here, and that point of intersection over here is 3 root 2's, and the y coordinate is just 2. That's the point of intersection. Again, thank you for paying attention.